GOM Inspect is a software tool that turns a 3D scanner into a CMM. We use it to check the geometric dimensions and tolerances of the parts we've just scanned. You may have seen me scan this same part in a different video using the GOM T-Scan Hawk, but what I'm about to show you could go for data from any 3D scanner. Let's take a look. So I've just completed a 3D scan of this timing belt cover using the GOM T-Scan Hawk, but this could have been done with any 3D scanner. The data set as of right now is entirely in the format of a mesh structure, which is to say it's made up entirely of very, very small flat triangles. And it represents all of the imperfections of the fabricated part. What I'm going to do next is bring into the project a CAD model which represents the idealized geometry of the same part, where all the flats are perfectly flat and all the dimensions are exactly as intended, and we're going to want to do a comparison between these two objects. Well, the first thing I need to do is align them to each other. I'm going to start out with a pre-alignment which automatically uses every surface on both geometries to try to match them up and do what is essentially a best fit. I'm going to keep going with this for the purposes of this video, but in some cases I might choose just a few select surfaces, maybe the mounting points, and do an alignment only by those surfaces so that I can see how correct this is relative to where it would sit in the assembly. But moving on, the first thing I usually would do is a surface comparison where we get a color plot that represents how close or far away any given surface on the scan is from where it is on the CAD. Green is where they match, red is where the CAD is smaller, and blue is where it is bigger, or above where it is on the scan. So this instantly gives me a sense of whether the part is warped, whether there are any features that are missing or too high or too low. And if I want a little bit more detail on that, I could add deviation labels on a few critical points. This can be really informative later on in my inspection report. And speaking of which, if I want this image to later be one of my report pages, I can go ahead and create a report page right now in this interface. I can choose the style of the page that I want, and I can make adjustments to the three-dimensional view and how it's going to appear on the page. I think that looks pretty good, and if I was doing this for real, I might change the text or apply my own logo or whatever kind of adjustments that I want to make, but I'm going to move on from here and keep on doing some more analysis. I might do an inspection section, which allows me to take a two-dimensional cross-section of the entire mesh and be able to take these measurements in more of a 2D kind of an environment. I'm going to create this and also isolate it on the screen. And I'll go to a normal view so that this can look nice for my report page. I'll add some deviation labels on my inspection section. And this is a little bit cluttered, so maybe I'll space them out a little bit more. And this could be another page of my report. But moving on for now, we'll go back to our 3D view. The last thing I might do is construct some primitive 3D geometry to match to the scan. In this case, maybe I want cylinders at both of the mounting holes. These I can use later to check dimensions like diameters or distances, or for other kinds of GD&T. Now on each one of these, the program requires that I define the measuring principle. Here I'm going to say it's a fitting element. And this is because we're fitting a cylinder onto the scan, which is an imperfect surface, the red in this image representing what might be there on the scan, and different kinds of fits will give us slightly different results. So if this was going to be a hole, and I'm going to be inserting some other type of rod into it, I might want to use the maximum inscribed element. If it's some other kind of geometry, I might want to use the Gaussian best fit. I'm going to check the diameter of each cylinder. And again, each one of these checks is given a pass-fail. These can be used to check distance, flatness, circularity, all different types of GD&T. And with the upgrade to GOM Inspect Professional, all of these measurements and checks can be preloaded into a report so that every part scanned can be automatically run through every single one of these checks with no additional effort. For any additional questions, please contact Trimex Solutions.